All right, so today's talk is on a healthy heart for life, and I think we've all had at least one person in our family or our lives affected by heart disease. I know I have, and we're taught that it's genetic or maybe has some family history, but it's not true. This thing is an environmentally caused disease, and we can prevent this and we can heal from it if we understand what's causing it. That's the whole purpose of this talk. So I hope you find it intriguing. I find it fascinating, so I hope you enjoy it. So, what is the heart? The heart is a pump, and it pumps blood, and it pumps blood to every single cell of your body. Okay, it's that important. And what blood does is blood's got nutrients in it. It's kind of like clean water getting to every cell, but it delivers a very important thing called oxygen. You can't make energy without oxygen, so if a cell doesn't get oxygen, it doesn't make energy and it dies. So, essentially, if the heart doesn't beat, cells don't get oxygen and you die very quickly. So we need the heart to always be beating. So let's go over some really fun questions about the heart that I think we're not taught, but it's really important that we understand. What makes the heart pump? Is it the blood? When I ask clients this, a lot of people say, "Oh, it's the blood. The blood makes the heart pump." But no, it's the other way around. It's kind of like a water pump, right? The pump is what pumps the water, but it's electricity that runs the pump. And your heart has an electrical system. So if you look over here, you got something called the SA node inside your heart. It's its own kind of pacemaker. So what it does is it creates this electrical charge over and over again, and the SA node keeps the heart rate consistent. However, most of us don't have a consistent heart rate all the time. You shouldn't. You should have what's called a variable heart rate. So your heart should speed up and it should slow down throughout the day. And what does that is the nervous system. So if you look at the nervous system, you have two parts to it going to the heart. You have this part down here that's called your sympathetic nerve system. That makes the heart rate speed up. And then you got this nerve called your vagus nerve, really important nerve that makes your heart rate slow down. We're going to talk about that a lot today. So it's really important to understand the nervous system speeds up and slows down the heart rate, whereas the SA node keeps it consistent. Next question, what gives blood to the heart? People don't realize this. Your heart is tissue too. It needs oxygen. And the blood that goes through it is not the same blood that gives it oxygen. So your heart actually has arteries on the outside of it called your coronary arteries. So inside of your heart you have all this blood that's being pumped out of this thing called your aorta, but the aorta will branch off right away and give blood right back through these coronary arteries. Okay, so these are all distributed. They deliver oxygen to the whole entire heart tissue, so your heart stays healthy as well. So 700,000 people a year. It's actually the number 2 cause of death in the United States. It's only second to healthcare. Our healthcare system kills close to 1 million people a year. People don't realize that. It's a very dangerous system. But heart disease is there, killing 700,000 people a year. And there's different types of heart disease. Number 1 is something called coronary artery disease. So if you take a look, we just talked about the coronary arteries over here, right? Flowing down, giving blood to everything. This is what a normal coronary artery should look like. This is what atherosclerosis looks like. So athero is a big fancy word for artery. Sclerosis is a fancy word for hardening. So what happens is this. According to, and again, these are theories. What happens is you get some damage inside of your artery. Your body sends cholesterol to plug it up, but it creates a little scar tissue. And as a result of that, you can see how much more narrow this artery becomes. As a result of that, less blood flows through it. Eventually, you get a little blood clot that forms, and it blocks the passageway so blood can't work its way through. And as a result, this whole part of your heart down here, for example, wouldn't get blood flow to it, so it wouldn't get oxygen, and that part of your heart would die, and that's what we call a heart attack. Okay, so heart attack is caused by coronary artery disease in the medical world. We're going to talk about the real cause of heart attack, and I'm going to get into this, but for all intents and purposes, this is what we're taught. And then you have something called congestive heart failure. It's a different type of heart disease. So a normal heart, you see all this space inside of this heart, a lot of room for blood to fill up. in a congestive heart failure, a lot of times the walls of the heart, all these muscles get overworked, so they get really big and bulky. There's less room for blood to flow into, and as a result, the heart is less efficient at pumping blood, and the blood will back up. It'll back up into the lungs, and it'll cause kind of this suffocation, and people will die from that. But a majority of people who die of heart disease die of heart attack. It kills about 500 to 600,000 people from heart attack. So I just want to show you a video of what we were just talking about. And again, this is the medical view.
The heart is responsible for pumping oxygen-rich blood to the rest of the body, providing the energy that the body needs to function. The muscles of the heart itself also need a supply of blood. The coronary arteries, one of which we see here, fill that need. Sometimes a cholesterol plaque forms on the side of the artery, reducing blood flow.
Now, I just want to pause it right here. I want you to realize something. Give me 1 second. Okay, so if you take a look right here, the video doesn't talk about this, but there's a crack right here. There's damage to the artery here. That's why cholesterol goes to the area. They don't talk about that. I just wanted to point that out. So,
if part of that plaque breaks through into the artery, platelets tend to attach to it, creating a blood clot, further reducing or blocking blood flow. The blockage in the artery prevents blood from reaching part of the heart muscle. Without blood, the muscle is starved for oxygen, causing damage to the heart muscle. The heart attack occurs because the damaged heart can no longer pump properly.
So I hope you guys see that. So what they're saying is this: cholesterol builds up in these coronary arteries. As a result, blood doesn't get out, and the lower heart tissue literally dies from lack of oxygen. So let's get more into this whole thing called cholesterol then. We need to understand what it is. So what is cholesterol? Cholesterol is essential to life. You need it for so many things. So for example, number one, cholesterol is a precursor to every hormone of your body. You can't make hormones without cholesterol. That means insulin, estrogen, thyroid hormone, testosterone all come from cholesterol. You need it to make vitamin D, which again, vitamin D is important for bone health, and it's a big cancer fighter in your body. You need it for your brain. 1/4 of all cholesterol is in your brain. It's actually what wraps your nerves up to make them really fast. So they give you quick thought, attention, and memory, and cholesterol is essential for healing. Cholesterol is there for new cell formation and scar tissue. This part is really important to understand. So if I cut my skin, my body will patch it up. It uses cholesterol to do that. But what you're left with is a scar tissue sometimes. That scar tissue is the same scar tissue you find inside the coronary artery. So when I paused that video and showed you that little cut inside that artery, cholesterol was going there to plug up that scar. And it creates scar tissue, which they call atherosclerosis. Now, they label it as good and bad cholesterol, but let's get into this. HDLs are supposedly your good cholesterol. LDLs are what they call your bad cholesterol. But here's the thing. Why would your body make something that's bad for you? LDLs are made in your liver. So, I mean, your body's so intelligent, it wouldn't make anything that harms you. So right off the bat, when they're calling it bad cholesterol, you just got to be careful in understanding that it's not bad. You need it. You need it absolutely to make all your hormones, to go to your brain, to do all this really important function of your body. Here's the other thing. HDLs and LDLs, they aren't even cholesterol. They're lipid proteins. So they're fats and proteins that ship cholesterol throughout your body. So they're actually more like the taxi cabs or the trucks that drop off cholesterol. Okay? Let's get into a little further. All cholesterol is made in your liver, or it's stored in your liver. And it has to get to your liver, to your brain, like we talked about. It's got to get to your heart. It's got to get to every single cell of your body to help repair things, to heal things, to create new cells, to create hormones, everything. So you need cholesterol in every cell. But cholesterol doesn't just go into your bloodstream. It needs a taxi or something to drive it around. So LDLs drive your cholesterol from your liver to other parts of your body, such as your brain, your heart, and your cells of your body. The reason they call LDLs bad is because when your coronary artery needs healing, it's the LDL that brings the cholesterol over there to create healing, but it's also what creates the atherosclerosis. Okay? So it's not bad, it's just what causes the atherosclerosis. Like on the other hand, HDLs do the opposite. When your body has extra cholesterol and doesn't need it anymore, your body doesn't want it hanging out. So you get these trucks they call HDLs that come in and they bring the cholesterol from the other parts of the body back to the liver. So the liver is kind of like the factory producing cholesterol, and you got your LDLs that bring it from the factory out and your HDLs that bring it from outside back to the liver. Now, what medical care does is this. They say, wow, we need to stop atherosclerosis. So they attack your LDLs. If you don't have LDLs, you cannot get waxing or you can't get scarring in your arteries around your heart. So they create this thing called a statin medication, which essentially goes to the part of your liver that creates LDLs and kills it. Okay? It also kills the part of your liver that produces coenzyme Q10, which is very important for the heart. But here's the question I want you to ask. How effective are these medications at preventing a heart attack? Of those 500 or 600,000 people a year who die from heart attack, how many of them are on statin medications? Most of them are. So here's the thing. They prevent you from having a heart attack by 1%. Now they'll say 33%, and this is how the study works. If you get 100 people on cholesterol medications, or 100 people, I'm sorry, as a control group, 3 people naturally die of heart attacks. Okay, 97 of them don't die of heart attacks. Now, if you put 100 people on statin medications, of that people, 2 of them die of heart attacks instead of 3. So you went from 3 people having heart attacks to 2 people having heart attacks out of 100. To me, that's a reduction of 1%, right? What they say is, oh, it went from 3 people having a heart attack to 2 people having a heart attack. That's a reduction of 33%. So it's all how you look at the numbers. It realistically prevents you from having a heart attack 1%. That's it, okay? Meanwhile, they increase your chance of diabetes by over 40%. So again, they also increase your chance of cancer and some other nasty things. So don't know if they're worth it. On the other hand, how effective is exercise at reducing heart attack? It reduces your chance over 40%. Diet, over 70%. A plant-based raw vegan diet will totally reverse heart disease. And it's not talked about, but it's been shown in multiple studies. You can find talks, literature on this. It's pretty amazing. So when you have, even if you're worried about your cholesterol levels, what makes more sense, going on a medication or changing your diet? I mean, it's over a 65% difference in how effective it can be. So here's some other medical consequences. If you take that cholesterol medication, here's what can happen. Number one is it stops cholesterol. You're not going to produce proper hormones. It doesn't just target the cholesterol going to your heart. It's going to target cholesterol creating your hormones. So that means you might reduce your hormones in your body. It's going to reduce your vitamin D, which means that cancer could very well be proliferating in your body. It's going to have damage to your bones. It's going to affect your brain as well because you won't get cholesterol into your brain. And then finally, it's going to reduce your healing. So there's some big consequences when taking these medications, and there's a lot of medical doctors talking about how nasty these things can be today. So I just want to point that out, what these are doing to your body, all the different side effects that they can have. So what I want to get at is this, guys. We need to target the real cause of a problem. As you saw in that initial video, there was damage to the artery that caused the cholesterol to go there. So think of cholesterol like firefighters. They're putting out all the fire inside of your body, those cuts, those things that are causing inflammation inside of you, and cholesterol puts out the inflammation. What we're doing as a society is we are showing up to the scene of the fire, we're seeing that there are firefighters there, and we're blaming the firefighters for the fire. But we have to understand what's creating that fire. We need to stop blaming the firefighter and blame what's causing the fire. And it's really easy. You've heard my other talks to understand there are 2 main causes: acid-forming foods, which we have an abundance of, and we have subluxation. We have a propensity in our society to eat meats, fats, high fat diets, lots of dairy, lots of meat, lots of grains. And what these things do is they break up and form acids, keto acids, things like that, that get into your bloodstream and they cause damage. And your body has to put that damage out with cholesterol. So if you have high LDLs, it means you have a lot of fire going on and your body needs to heal a lot more. So it's never a problem with the cholesterol. But here's the next question. The whole idea that cholesterol causes a heart attack is a theory. It's not fact. I want to tell you a story about this study that was done on this dog. They took this German Shepherd, and this doctor wanted to see how long a dog could live with an occluded coronary artery. So he put the dog under, took the first coronary artery, tied it off, and cut it out 100%. So he had 100% occlusion of his first coronary artery. Woke the dog up, and to his surprise, the dog was totally fine. So he said, the dog can survive with two collateral arteries. Let's put him under and occlude the second one. Put the dog under, tied off the collateral artery, brought him back off the anesthesia, and guess what? The dog survived. Finally, he put the dog under again and tied off his third coronary artery, so the dog had 100% occlusion on all three coronary arteries. Brought the dog back to life, and guess what? The dog did not have a heart attack. Okay? How does that happen? How do you have 100% occlusion of coronary arteries and not get a heart attack? You have to understand this. During a heart attack, we know for a fact when you study heart tissue, if someone had a heart attack, that the tissue in the heart died from a lack of oxygen. They can also do blood flow studies. Now, the whole issue is, the theory is that the coronary artery gets blocked off and the lack of blood flow gets to the heart. But when they study the heart of a heart attack, that's not the case. So what you're getting is a heart tissue that's dying from a lack of oxygen, but there's still blood flowing to that. So how does that happen? Now here's what's happening. You have something called collateral arterial formation, which is this. Let me pull up my laser pointer so I could really go. So if you take a look over here, this is a coronary artery, for example. If you get a blockage, your body is very intelligent. What it will do is create new pathways around it, so that blood flow, instead of it all going through, is now going to build these alternative routes. It's kind of like if you have an accident on the highway, we don't just have people stand there, you open up different alternative routes for the traffic to go down. So as a result, you can have 100% occlusion and not reduce the blood flow to an area. Pretty cool, right? So if you take a look, this is a heart. Here's the collateral arteries, these big arteries here. But you see all these little arrows, all this happening. This is collateral artery formation. So what it means is this. When we're getting these clogs in our coronary arteries, your body's not stupid. It's building these little branches around it and bringing blood flow to it. So when you're having a heart attack, it is not caused by a blockage of the arteries. I hope that makes sense. So here we are. You have tissues that are dying from lack of oxygen, but there's not a lack of blood flow. So a heart attack is a lack of oxygen to heart tissue, but not caused by obstruction. So then what causes it? What could cause a lack of oxygen? And to understand this, we need to understand the nervous system. And your nervous system has two parts to it. You have what's called the sympathetic nervous system, which is your fight or flight system. So you know when you're out in the woods and you see that bear, for example, and you get scared, that's your sympathetic nervous system. And then you have the opposite of that. It's called your parasympathetic nervous system, which is your rest and digest. So pretty much how this works in nature, you go out, you see something that startles you like a bear, okay? Your heart, what does it do? Your heart rate, your sympathetic nervous system kicks in. It tells that SA node to start beating faster, and your heart starts to beat faster. Let's say you run and you get away, and now it's time to relax. So your parasympathetic nervous system kicks in, and it brings the heart down and relaxes it, okay? If we're looking at this and the nervous system, this is how it's innervated. So if you see coming off here, which is the very lower part of your neck, your upper middle back, you have these nerves that branch out and come out. They go to the heart, just like that. These are the nerves. It's called your sympathetic nervous system. These are the ones that make your heart beat faster. Now this blue nerve up here, it's coming off the base of your brainstem. It's called your vagus nerve. It's part of your parasympathetic nervous system, and this is what flows to the SA node and tells it to, hey, slow down, okay? And you need both systems to work. All right, so just to show you on the body here, this part of the spine down here in red is where you see the sympathetic nervous system. Those are the nerves in the base of the spine that come out, and they're the ones that tell the heart to speed up. And then at the base of your skull, you have what's called your vagus nerve, which is your parasympathetic nerve system, which is what branches out at this part of your spine, the very, very top bone of your neck, and tells your heart to slow down. So your vagus nerve and heart health. Let me ask this question. What would happen if your heart beats fast, but the vagus nerve, the parasympathetic nerve, didn't work? So your sympathetic nerve, so you see that bear and your sympathetic nervous system gets your heart beating really fast, but the parasympathetic nervous system doesn't work. Your heart wouldn't slow down, and as a result, your body would need to burn through all of its oxygen. So when your heart's beating really fast, it's burning through a lot of energy. It's burning up all of this oxygen right away, okay? It's kind of like if you're working out and you're doing sprints. What happens is when you burn through all of your oxygen, you start to use lactic acid instead. And what ends up happening is you get cramps, right? Same thing is happening in your heart. You're burning up all of your oxygen, but the problem is it's not like muscle tissue where you can keep going and have your cramps. What happens is your heart tissue doesn't have enough oxygen and it dies. This is the cause of a heart attack. The heart attack is caused by your nervous system that is not working properly. A heart attack is caused by when your sympathetic nervous system, your fight or flight, gets engaged and then it can't slow down. And that's what they find historically when they measure somebody who's had a heart attack and they do an autopsy. They find that person's heart was stimulated before they had that heart attack. So they get nervous, their heart starts beating fast, burns up through all of its energy and can't slow down. So this is kind of what we're talking about. If this is a balance, you're supposed to have equal balance left and right side. Well, when somebody who has a heart attack, their sympathetic nervous system is so dominant over their parasympathetic nervous system, they can't slow down. This can also cause congestive heart failure. So how do you build muscle? You work out over and over and over again. What happens is that muscle gets bigger. Well, look at your heart. Same thing. Over here is your heart. Here's the normal muscle tissue. Now, if you are getting historically into this stressed state, this fight or flight state over and over again, that muscle builds until you have what's called congestive heart failure. So when we're understanding this heart failure and this heart attacks, it really has very little to do with the blood system and has much more to do with the nervous system. So problems with the nervous system causing heart attacks and heart failure. So what causes this problem in the nervous system? Okay, the most important one, I believe, has to do with this top bone of your neck. So remember, your vagus nerve comes out right here, right where my mouse is triggering, right where that top bone of your neck is. Most people have the top bone of their neck misaligned, about 95% of the population. And what happens on some people is the way it moves out is it compresses that vagus nerve and makes it not work properly. Just to show you another diagram of this, this is the atlas vertebra. When it slides out of place, it literally compresses your brainstem, which is the part of your body where the vagus nerve comes out to tell the heart to slow down. I just want to show you this on a model. This is your vagus nerve right here, coming out, going to your heart. And that vagus nerve also goes to your lungs to tell your lungs to slow down, take deep breaths. And it goes to your digestive tract to help you digest food. So when you have that misalignment of the top bone of that neck, not only does it make your heart beat faster, but it also totally backs up your digestion. I can't tell you how many people we see that we just adjust that top bone of that neck, and somebody who's only go to the bathroom maybe once or twice a week starts to go every day. Pretty simple. Here it is again. If you follow the heart on this diagram, you follow this nerve back, which is the vagus nerve, and you take it all the way back to the spine. Look where it goes. right to where that atlas is, right in there. So when that top bone of your neck misaligns, you're putting a lot of pressure in this area of your nervous system, which is the nerves that are coming out and controlling this whole branch. I want to talk about the humpback and heart health. A really good way to tell, and no one talks about this, if you are a candidate for heart attack is what's called a Dowager's hump. And many of you watching this might notice that the back of your neck, the lower part, you might get this hump right here. And your head's starting to go forward. But people don't relate that to the nerve system. This is just a real life model. See that hump right there? And then from the side, you'll see sometimes this is a really bad one. You'll see people with this hump. So what's going on physiologically with these people is this. The first thing that happens is the top bone. This is normal on the left. We should see your head over your shoulders, right? What happens when that top bone misaligns is it brings your head forward. So as that top bone presses forward, it brings your head forward with it. It can compress the vagus nerve. So right away, that parasympathetic or that vagus nerve can't slow the heart down. But the other thing it does is this. Number two, it brings the head forward so much that it puts a lot of strain on this part of the spine. That's where you get that hump, that Dowager's hump that we were just talking about. As a result, the spinal cord gets stretched in this area. It can cause disc herniations in your lower neck. That's what causes it, and degeneration. And it actually activates the sympathetic nervous system. So it does two things. Number one, it stops the vagus nerve from working, and it activates this part of your system. So the heartbeat will be increased by the stretching of the sympathetic nerve system, but it won't be able to slow down because of the pressure on the vagus nerve. This is a real life example. This would be a normal spine. This is what we want to see. This is actually a client of mine. You see how forward her head is now. If I draw a line straight down, her head is actually a few inches forward right now. So it's creating this little hump in her back. And again, when we do her nerve graphs, which I'm going to show you in a bit, what you'll see is that a lot of activation in these nerves and a lot of pressure on the nerves up here. This would be somebody who would be a candidate for having a heart attack if they didn't get their spine fixed. Amazing stuff. Okay? Oh, let me get through here. Pretty amazing stuff that happens, guys. So, how to have a healthy heart for life has very little to do with the cholesterol. Now, the cholesterol can be an indicator. The plaquing can be an indicator of how much acid-forming foods you're eating, how much clinical damage you're having. So it can be an indicator of health, but not for heart health. It's not what's causing heart attacks. What we need to do is have a very healthy parasympathetic nervous system. In order to do that, a couple things we need to do. Number one, most important, is get that upper cervical spine fixed. You only do that by seeing upper cervical chiropractors. These are people who do not twist, crack the spine. They take very delicate x-rays, very specific x-rays of the spine. Please do not ever get adjusted by a chiropractor who does not x-ray your spine or measure your nervous system. They should always be measuring it. So these are specialized chiropractors. If you need help finding one in your area, please let me know. We'll be more than happy to help you find one. Nutrition. Acid-forming foods do stress the adrenal glands. So if you sit and you have this standard American diet of meat, dairy, eggs, processed sugar, grains, these things will drive the adrenals to overwork. And what ends up happening is you get into a fight or flight state over time. So really sticking to fruits. Fruits actually have a calming effect on the nerve system and help your parasympathetic nervous system. Environment. Here's the thing. Our bodies are evolved to be in nature. And when we're in nature, your brain works completely different. It releases endorphins and it slows the brain down. And now think of the environment that we live in all of the time. We live in a state of stress. So we need to get outside way more often, be out in nature. There's something called forest bathing where you walk into a forest, take deep breaths. It calms you down. It makes your parasympathetic nervous system relax. And take breaks from your work often. Get away from the cell phones, get away from the computers. What we're doing is we're flexing our fight or flight system more and more and more and more. And we're not working out our parasympathetic system when we live in our everyday world. So you need to take breaks. Exercise, we need to change our exercise. Instead of going for long runs, it's actually better to work on your heart rate variability. So what you want to do are these exercises, we call them peak 8s, or high intensity workouts, which what you do is you sprint as hard as you can, or you do like an elliptical for as hard as you can for 30 seconds, get your heart rate beating really fast, and then you go really slow as you can for a minute and a half. And you do that 8 times. And what you're doing is you're working on your heart beating fast, and then you're working on it slowing down. So you're kind of working out your parasympathetic nervous system by doing it. Finally, getting into personal growth and development. One of the best things I ever heard is measuring the level of problem and the level of the person. What I mean by that is this. You might have on a scale of 0 to 10, you might have a level 5 problem, right, which is a middle of the road stress. If you're a level 2 person, a level 5 problem is very stressful. But if you build yourself up, if you're a level 10 person or a level 8 person, a level 5 problem doesn't seem stressful at all. So it's not about working on problems, it's about working on you, making yourself a better person. And how do you do that? Best thing to do is meditate often. Get quiet, get in the aloneness. Sit in a dark room with no stimulation. Okay? Read uplifting books that are going to help you grow, and having a spiritual practice of some sort. Okay? Guys, if you work on these things, getting your atlas adjusted by far is the most important. Getting your nutrition fixed, being in a healthy environment, working on your exercise of being intense and then resting, and then working on yourself and getting to that place where no problems affect you, that's the key. That's what's going to help your heart. That's what's going to help you be in have that healthy heart the rest of your life. Remember, your body was created to coincide with nature, live according to the laws of nature, and you can expect health. Pure Life Health Centers. Here's my name. Here's my number. This is how you contact us. We offer free consultations and exams to anyone who comes in. So please, if you have any questions or comments or concerns about this, give us a call. We love you. I hope this helps, and I hope you have a healthy heart the rest of your life.